Good morning, sir. This is Sashi Reddy from CSC, and my topic is about to find the coefficient in a given expansion using multinomial theorem. Introduction to multinomial theorem. The multinomial theorem generalizes the binomial theorem for expressions with more than two terms. It allows to expand expressions to form x power 1 plus x power 2 plus and so on x power k whole power n. The coefficients in the expansion involve combinations of the components of each term. The expression. What we are examining the expansion a plus 2b minus 3c plus 2d plus 5 whole power 16. Our goal is to find the coefficient of the term a square b cube c square d power 5. This involves contributing terms from different parts of the expression during expansion. Identifying required exponents. The required term is a square bq c square d power 5. We need to determine how many times each term in the expression contributes to this term. This involves solving for the specific powers of each variable in the multinomial expansion. Setting up the equation. Let n1, n2, n3, n4, n5 be the number of terms a, 2b, minus 3c and 2d and 5 are chosen respectively. The equation to satisfy is n plus 1 plus 2, n plus 2 plus n3 plus n4 plus n5 equals to 16. We also have the constraints n1 equals to 2, n2 equals to 3, n3 equals to 2 and n4 equals to 5. Based on this term we want. Solving for the remaining term. Substituting the values from the previous slide, we find n5 equals to 16 minus 2 plus 2 plus 3 plus 2 plus 5. That equals to 16 minus it's 12. It is 4. Hence, we have n1 equals to 2, n2 equals to 3, n3 equals to 2, n4 equals to 5 and n5 equals to 5. n5 equals to 4. By multinomial theorem, a plus 2b minus 3c plus 2d plus 5 whole power 16 equals to 16 factorial by n1 factorial into n2 factorial into n3 factorial into n4 factorial into n5 factorial and into a power n plus n power n1 into a 2b power n2 minus 3c power n3 2d power n4 5 power n5. When n1, n2, n3, n4, n5 equals to n, that equals to 16. A plus 2b minus 3c plus 2d plus 5 whole power 16 equals to we consider that as an equation 1 and dividing the n powers and constants and variables apart. We have to find the coefficient of a square b cube c square d power 5. Here a square equals to a power n1. n1 equals to 2. Here bases are equal, powers must be equal. bq equals to n square. Here also bases are equal, powers must be equal. Here also in C also n3 equals to 2. Bases are equal, powers are equal. d4 also bases are equal, powers will be equal. Let n5 is here and 16 minus 12 equals to 4, that is n5 equals to 4. From equation 1 a plus and we are substituting the n1, n2, n3, n4 value, n5 values in the equation 1. Then we get 16 factorial by 15 into 625. Here the coefficient of the a square b cube c square d power 5 is 16 factorial into 625 into by 15. And lastly, conclusion. The coefficient of a square bq c square d square in the expansion is a product of combinatorial and arithmetic calculations. This example illustrates the power of the multinomial theorem in handling complex expansion. Understanding this process enhances our ability to tackle similar process treatment problems in confidently. Feel free to adjust any part of content or let me know let me know if you need future elaboration on any specific slide. Thank you, sir.